Okay, so today we're going to be learning how to solve linear equations and inequalities using the calculator. So here's the calculator instructions on your notes for you, so you can always refer back to that. We're going to start with number 1, and we're going to be using graphing. Okay, so number 1, it says negative 2x plus 6 equals 3. So algebraically, we would normally subtract the 6 over on the right side, and then we can divide. Okay, but today we're just going to do it on the calculator. So I want you to, in y1, you're going to type in your left side of your equation. So negative 2x plus 6. And then in y2, you're going to type in the right side, which is 3. So using your calculator, y equals, so negative 2x plus 6 needs to go in y1. 3 needs to go in y2, and we want it to be in standard viewing window, so make sure that you're in zoom 6. Standard viewing window goes from negative 10 to 10 on the x and y axis. Okay, so notice that we have 2 lines here and that they intersect. Okay, I want you to sketch these on your graph. You don't have to worry about any of the numbers on your x and y axis whenever you're sketching it, but I do want you to find their point of intersection. That's what you're going to be looking for. So on your calculator, to find the point of intersection, you're doing second, count or trace. Number 5 is intersect, and then you should have a blinking cursor on one of your lines. You're going to hit enter 3 times, and it should say intersection when you have found your intersection point. Okay, so if it doesn't say intersection, you're not quite done yet. So your intersection point on this one is 1.53. Now, normally when we're solving a linear equation algebraically, we're finding what x equals. So to solve the equation here by using the calculator, you're just going to be looking at the x value of your point of intersection. So x would equal 1.5. Okay. All right, to check it, you would check it the same way, just plug it back into your original equation and it should be true. It's the correct solution. Okay, so moving on to number 2. Now, notice here we have parentheses. Normally we would distribute if we were solving algebraically, but we don't have to do that. Okay, we're just going to use the calculator. So the left side, I want you to put into y1 with your parentheses. So wherever you see parentheses, make sure you put it. And then in y2, you're going to type in that right side, which is 4 times 2 minus x. We're going to do it the same way. We did the first one. Go to y equals. Figure out what we already have. I'm typing in 3 open parentheses x minus 2 close your parentheses plus 7. And then y2 is the right side of your equation, which is 4 open parentheses 2 minus x, and then we're going to graph. We already put it in standard viewing window on number 1, zoom 6, but if it looks weird and it's not going from negative 10 to 10 on the x and y, you can push zoom 6. Okay, so notice they also intersect. And we're going to find that point of intersection. So what we did on number 1, second, count or trace, number 5. You should press enter 3 times and find your intersection of 1, 4. Again, we're solving, so we're finding what x equals. So x would equal 1. You can check it, plug it back into the original, it should be true. Okay. All right, let's take a look at 3. So 3. We have an equation. We're typing in the left side in y1, right side in y2. So 5x minus 6, 3 open parentheses x plus 2. Okay, so now notice on this graph that we don't see the point of intersection. Okay, some calculators allow you to find that point of intersection if you can't even see it. but most calculators are not able to find that. So what we're going to do is we're going to change the window because we know that we can tell that it's going to intersect up at the top because it's getting closer and closer. Okay, so we're going to go to window, which is to the right of y equals. You're going to adjust your window. If we're wanting to go up higher, you would need to change the y because the y-axis is the vertical. And if we're going higher, we're wanting to change that y max at the top. So notice your y max on your standard is 10. So let's go ahead and just try do 25. And notice we're able to see that point of intersection there. So now we can do, let's sketch it. And then finding that point of intersection, second calc 5, let's enter 3 times. And then the intersection point is 6, 24. Again, when you're solving, you're finding what x equals. So x would equal 6. Check it by plugging it back into your original equation, and it should be true. Okay, so number 4 is a little different. We have a fraction, but we also have an inequality instead of an equation. Okay, we're still going to graph it the same way. Left side's going to go in y1, right side's going to go in y2. Now, on your fraction here, remember that you need to put parentheses around your fraction when you're plugging it in. So on your notes here, I'm going to go ahead and write parentheses 1 divided by 2. That's how you would enter in the 1/2 x and minus 3. The y2, right side of your inequality is negative 4. Okay, so we're going to plug that into y1 and y2. So parentheses 1 divided by 2, close your parentheses x minus 3, and then your y2 is negative 4. I'm going to go ahead and go back. We adjusted our window, so I'm going to go ahead and go back to that standard viewing window, which is zoom, which is the top middle, 6. And so now we're back at that standard. Okay, so we have 2 lines that intersect. Sketch that, and now I want to find that point of intersection. So second calc 5, and then the intersection point would be negative 2, negative 4. Now, on the other ones, we just wrote x equals negative 2. Okay, we're not just writing what x equals on the inequalities. We have to shade and we have to figure out what our solution will be. Okay, it's not just one number. All right, so anytime you're solving the inequality, you need to look at your inequality sign. Anytime you have a less than or equal or less than, you'll be shading below. Anytime you have a greater than or equal or a greater than sign, you'll be shading above. This shading will help you with determining what your solution will be on inequality. Okay, so looking at this one, notice we have less than, so we would be shading below this horizontal line. So if I shade below, I only care about the x. So really, all I'm going to shade is just this portion of the line. We don't have to shade all of that. We're not looking for ordered pairs. We're looking for x values. Okay, so I'm just shading that portion. So knowing that, we're going to write our solution. So we'll start with x. Our x value here is at negative 2. And notice where the shaded part is, our x values are getting smaller because it's going to the left. We're looking at the x values. So x would have to be less than. How you know if it includes that number, look back at your original. Notice that it's less than or equal here. So it will also be equal to here. So less than or equal to that x value that we found on the point of intersection, which is negative 2. Okay. Now, some of you might be thinking, oh, well, why can't we always just use the same exact sign? Well, because whenever you remember when we were solving algebraically, you're not always going to keep that sign the same, because with inequalities, if you divide by negative or multiply by negative when you're solving algebraically, then you have to change that inequality sign. Okay, so it's not always going to be the same as the original. That's why you have to shade and find what your solution will be. Okay, so let's look at number 5. So inequality. So the left side is going in y1, 3x, negative 3x plus 8, and then y2 would be 12. So we have negative 3x plus 8 and 12. Now notice we only see one line. We should see 2. So we're graphing 2 different things. If you notice in y2, y is going to equal 12. On a standard viewing window, y equals 10. So we're going to have to adjust that. So go back to your window. We're going to change the y max. It's at 10, but we need it to be at 12. So I'm just going to choose 15. So now notice we're able to see both of the lines. So I'm going to sketch it. And I'm going to find the point of intersection. So second, calc 5. Press enter 3 times. It should say intersection. Notice you ended up with negative 1.33 repeating 12. So that would be negative 4/3 in fraction. Okay, so looking at your inequality of your problem at the top, it's greater than, so we would need to shade above. So looking here, here's our horizontal. Above it would be this section of that line there. Okay, so that x value right here at that intersection point is at negative 4/3 or negative 1.3 repeating. So notice that the shading, it's going to the left. So as we go to the left, our x values are getting smaller. So it should be x is less than, back at the original, it doesn't include it on the original. And so that would be negative 4/3 or the negative 1.3 repeating. Okay. So now notice on that one, we start out with a greater than, but on our solution, it was a less than. The reason for that, if you were solving algebraically, you would end up having to divide by that negative 3, which would change that inequality sign. Okay, so that's why it's important on these, when you're not solving algebraically, that you shade, so that way it will help you with determining your inequality sign on your solution. Okay, let's look at 6. So y1, we have 4 minus 2x, and then y1 from the left side, and then y2, we have negative 3. So we have 4 minus 2x, and we have negative 3. I'm going to go ahead and go back to Zoom 6, because we changed the window on that last one. We have 2 lines. Finding their point of intersection, second, calc 5. Let's enter 3 times. We should get 3.5, negative 3. And then we'll need a shade before we can find the solution. So notice it says less than or equal, so we will shade below. So here's our horizontal, shading below, so this portion of our line there. Notice that our x value there is at 3.5. And notice as we're going this way where the shaded part is, the x values, because that's all we care about, the x values are getting larger. So x should be greater than, it was equal to on your inequality on the top, so it should be also equal to on your solution, 3.5 or 3.5. Okay. You can check that by plugging in any number greater than 3.5. It should work. It should be true, including the 3.5. All right.